Good day. My name is Okwarani Deji, and together with my group member Mzie Aguju Chukwemeka, and the project topic of our presentation is installation and maintenance of a solar system for a small residence in Nigeria. The motivation behind the selection of this topic is because of the epileptic power supply in our country and how many households many households in Nigeria are having difficulties having day-to-day electricity. The content of our presentation goes thus. First, we have the introduction part, and we have the objective of this project. We have the literature review. We have the methodology. We have the system design and simulation, which was done using software PV system. We have the feasibility analysis where we compare the economical and environmental feasibility, and we have the discussion and conclusion.
First, we have the introduction. For sustainable growth and to ensure the connection between life and the environment, renewable energy is the best option for the coming generation. The adoption of renewable energy involves both government and non-government organizations. As society continues to advance, the demand for energy supply is gradually rising. Due to technological improvements, environmental friendliness, and availability, renewable energy has been demonstrated to be effective and one of the best options for assuring the world's future development. Considering this, replacing outdated energy sources like oil and gas with renewable ones like solar, wind, and hydropower, we can have an effective and positive impact rather than a negative one. Now, one of the most popular green technologies is solar energy, and with the recent advancements in technology, falling costs, and government policy favoring the growth of renewable energy, it has undergone substantial development. As of 2009, the price of solar energy in Nigeria was approximately $8.50 per kilowatt hour. This is quite unfavorable given that it was expensive in comparison to other energy sources. However, recent market findings show that the price has significantly dropped to approximately $2.77 per kilowatt hour, making it realistic, appealing for government and also private individuals to invest in this venture, particularly for a nation that has good solar potential but struggles with the lack of power supply, as is the case of Nigeria. This study is intended to integrate the solar power standalone system and also monitor its results remotely. The adoption of residential solar systems in Nigeria has surged recently, fueled by the country's abundant solar potential. Advances in solar technology, such as efficient PV panels, batteries, and also smart inverters, have supported this growth. Economic evaluations reveal that despite initial high costs, long-term energy savings make solar investments quite beneficial. Proper installation, guided by comprehensive site assessments, ensures optimal performance, while regular maintenance tailored to local conditions extends the life of the system. However, challenges such as scarcity of skilled installers and insufficient regulations remain a problem. Previous research in this area of study underscores the significance of renewable energy in solving Nigeria's power challenges, technological adaptability in tropical conditions, cost-benefit analysis, and the role of government policies. These studies collectively offer a comprehensive view of Nigeria's residential solar landscape and directions for future endeavors. Looking at some of the previous work done in this area of study, we have Said et al., whose study reinforced the effectiveness of monocrystalline and polycrystalline PV panels considering the climate of Nigeria. Okaku demonstrated that despite high upfront costs, the long-term financial benefits outweigh the initial investments due to consistent energy savings of a solar-powered system, while Okonkwo's study argued that proper site evaluation evaluations lead to more efficient installations and better system performance. The first phase of our project involves conceptualizing all the potential components of the proposed system. In the figure on the left hand side, you can see our electrical load, which is basically the load profile of a typical Nigerian home, which mainly involves a refrigerator, a TV, a standing fan, computer, and lighting. Also, we have our solar battery, our smart solar inverter, the solar array, and also connection to the grid. We focus on meticulously and specifying and assembling each component, ensuring that they function together seamlessly in order to fulfill our defined objectives. Following the deployment and assembling of these components, we will conduct a feasibility study to evaluate the practicality and viability of the system in the specific area. This study will involve assessing factors such as sunlight availability, energy generation potential, and economic considerations. To monitor the system's performance and output remotely, a smart logger will be connected to the system. A smart logger is a device used to monitor and collect data from the various sensors and send that data to a central server or cloud-based platform for analysis and storage. Some of the components of a smart logger include the PV array, the temperature sensor, which measures the ambient temperature of the environment where the smart logger is installed. This information is essential as temperature affects the performance of the PV array, and high temperatures can reduce the efficiency of the panels. The Wi-Fi sensor is used to establish a wireless connection to the internet. It allows the smart logger to transmit the collected data to an IoT server or cloud platform without the need for physical wires. Now, the IoT server is a cloud-based platform or a remote server that receives and stores the data sent by the smart logger. It is responsible for data storage, analysis, and providing access to the data for users through various interfaces such as mobile apps and web applications. The microcontroller on the smart logger basically serves as the brain. It controls and coordinates the overall operation of the system. It reads data from the PV array, the temperature sensor, and the Wi-Fi sensor, and also processes the data, performs necessary calculations, and prepares the data for transmission to the IoT server. The smart logger has 5 steps of operation, which include data collection, data processing, data transmission, data storage and analysis, and remote access for the users. Additionally, we will use the ShinePhone app, which is specifically designed for remote monitoring of solar power systems. This app enables real-time monitoring of the system outputs, providing valuable insights into its efficiency and performance.
The simulation and installation results. We make use of a software which is called PV System. It is the software tool for simulating and analyzing photovoltaic system. So the first thing we got was our sun path. What is our sun path? Sun path refers to the trajectory of the sun across the sky throughout the day and the year. And what it does in PV is that it helps us visualize and understand the solar position with respect to the PV system's location. So the next thing we get on our left hand side is the arrangement and the grid system definition. So we selected the PV module, which is CSI Solar. We got our inverter, which is Growatt New Energy, which has a capacity of 5 kilowatts and 50 to 550 volts. And the design of our array and numbers of modules and string. The numbers of modules we made use of was 10, and the number of string we made use of was 1. Having gotten our sun path, the next simulation result we got was the reference incident energy in the collector plane. What does this represent in our simulation? It represents the total solar energy incident on the collector plane. It is the solar energy that would be available to the PV system without accounting for any losses and inefficiency. On our left hand side, we demonstrated the battery that was used. The battery that was used was Naredel, and we have 12 volts with 200 Ah capacity. And our battery was 4 batteries was connected in series and 1 was connected in parallel. The connection of our system is done. Further proceeded to get a simulation result, and the next one we got was normalized production. And the normalized production is the ratio of actual energy output of the PV system to the expected energy output under the ideal condition. It is usually expressed as a percentage and helps us to assess how well the PV system is performing compared to its theoretical maximum output. The other simulation we got was the normalized production and loss factor. What does this one do? They are used to account for various losses in the PV system. Losses such as shading, soiling, temperature effect, and the system downtime. In our simulation result, and we got the incident irradiation distribution. This term in our simulation refers to the distribution of solar irradiance incident on the PV array surface during a specific time. The PV system provides this information to show how the solar is distributed over the PV panel surface, which can further help us to identify the areas of shading and uneven distribution. Next, we have our performance ratio. The performance ratio is a metric that is used to evaluate the overall performance of the PV system. It is the ratio of the actual energy output of the system to the expected output under reference condition. This our performance ratio can help us to show whether our PV is underperforming or not. The PR value close to 1 indicates that it's of good performance, which means our PV and our operation of the system is of good performance. But if it's way and less beyond 1, then it shows that our system is underperforming. So with our PR system being 0.8, which is very close to 1, it shows that the system in which we implemented is performing well and is not underperforming. The simulation result that was included in our slide presentation is the array voltage distribution. This term refers to the distribution of voltage across the PV under different operating conditions. By understanding the array voltage distribution is essential for designing and optimizing the electrical component of PV system, such as inverters and wiring. We also added the daily system output energy, which represents the total amount of energy generated by the PV system in a single day. It is the sum of all the energy produced in the PV panels during daylight hours and is a fundamental parameter for assessing the system productivity and economic viability. More simulation result was gotten and we added it in the final submission of our supporting file. So in summary, PV system uses these terminologies to analyze and assess the performance of PV system, taking into the account of various factors that influence the energy production and efficiency of the system. So our simulation result and analysis is done. We then move on to the next part, which is the feasibility study of our research. Feasibility study was conducted by comparing two systems. The first system we compared was the solar system, and the second system we compared was the generator system. We compared both systems economically and environmental, and we eventually arrived at our desired result, which shows that solar system is more economical and environmental favorable compared to generator system. I move on to the implementation and calculation of this feasibility study. The calculation of how we are going to go about our feasibility study. First, we have the PW is equals to CR multiplied by PR. Our PW is the present worth of our system, and CR is the cash flow at each period, while our PR is the present worth value. So the PR can be calculated using 1 divided by 1 plus D close brackets N, and the D is the discount rate where the N is the time of the payment, and our CR can be calculated using this formula: the operation and maintenance cost plus the overall cost plus the replacement cost minus the salvage cost. And putting all this calculation into the implementation, we can access our system, generator system and solar system, which will be done in the next preceding slide. Lifespan of our system was 25 years, and will show and practicalize the maintenance cost and the present worth of our system after 25 years. in our generator system, it shows that after 25 years, the present worth of our equipment and the amount we've used on the maintenance and replacement and overhauling and everything will amount to $63,268. Proceeded our economic feasibility, and when 25 years span was shown in solar system, after the maintenance, cleaning, the replacement battery and the inverter, we have our present worth to be $43,932, which is of course lesser when compared to generator system. Moving on to the discussion and conclusion of this project slide presentation. Solar system is increasingly recognized as a practical substitute for conventional energy source. The major advantage that is noticed in solar system implementation is the fact that the upfront cost is so much when compared to generator system. But after this upfront system, it has shown economically that over the time the cost of investment decreases significantly due to substantial price drop in solar panels and inverters, which is not the case when being compared to generator system, as the cost of maintenance over the years and constant servicing and everything gives us much more maintenance cost when compared to solar system. Aside from the economical feasibility, we also find out that solar system is more environmental friendly, as there is no production of toxic gases into the environment when being compared to generator system. Solar system does not need to irradiate toxic system into the environment that will be toxic to the environment, and using solar system, it's net noisy, which does not pollute the environment with noises as of when compared with generator. Comprehensive research into solar panels could also be explored, and based on this comprehensive analysis including simulation outcome, a review of prior research, we assert that households in Nigeria should transition to solar installation in lieu of traditional power generation method, which is the common thing that households in Nigeria use. So as a result of this practical implementation, we hereby employ the household in Nigeria that adopting this solar system is more better than the present use of the generator system that is being used. We have proved that economically and environmental, solar system is more friendly when compared to conventional source of energy, which is system. The success of this presentation and this project was down to the help provided by Professor Jamil. Special thanks to Professor Jamil for supporting us and guiding us all through this project presentation, and a special appreciation to the Faculty of Pure and Applied Sciences for providing us with necessary resources so as to gather what we gather and helping us to achieve the success of this project.